Hey there, this is Mr. Bean, and we're going to learn about conic sections in this unit in Algebra 2. What in the world is a conic section? A conic section is when you have a cone and you slice it at any particular angle. So for example, when we take this cone and slice it at an angle like this, where you can take it off, the shape that it creates is a parabola. That's the first thing we're going to be studying in this unit is parabolas. We've studied them before, but we're going to do some interesting different things with it. Some cool applications with that, like satellites. Then, the next thing we'll look at, if I can put this thing together, the next thing we'll look at is called ellipses, where you slice the cone at an angle like this, not through the base, but just at an angle, then you take that thing off, and it looks, if I can pull this off, it looks like an ellipse right there. There we go. Again, some interesting application problems there. Then if you slice it right across that is parallel to the base, it creates a circle, so that'll be the next thing we study, circles. And then lastly, this thing called hyperbolas. Looks very similar to a parabola. This is what it looks like. It looks very similar. It's not exactly the same. The equations for those things will be different. And that's where you slice it perpendicular to the base, where you slice it right down the middle. So the idea with what we're studying is we're going to be looking at both the equations for all these conic sections, and we're going to be looking at the graphs of them. And hopefully along the way you'll get some interesting little application problems that you'll love, because I know that's your favorite part. Alright, on to our first lesson on parabolas.
The first thing we need to talk about in this lesson is the distance formula and midpoint formula, going back to our days in geometry. Now the distance formula might seem a little complicated, but really it's just the Pythagorean theorem. If you have 2 points that we're searching for the distance between them, this distance d, if we could take the x values and the y values and use the Pythagorean theorem and then solve for d, you would get the distance formula. See, if a, it's the distance between, or I guess I should say the difference between the x's, and then the difference between the y's, and there you go. And it's really just the Pythagorean theorem. We'll solve for d. Midpoint formula, the way I think about midpoint formula, if we have 2 points again, and we're just trying to figure out what is the middle of those 2 points, it's really just the average of the x's and y's. So you take the 2 x values, add them up, divide by 2. Take the 2 y values, add them up, divide by 2. So you might even write that down in your notes, that it is the average of the x's and y's, because that's going to come in handy for this entire unit when we're working on needing to know the distance or the middle of 2 coordinate points. Next is a reminder on what we've studied so far this year dealing with parabolas. First thing is we did standard form. Mr. Sullivan taught us ax squared plus bx plus c. Hopefully you're remembering that, familiar with it. Then there was also vertex form, which is really nice when we're having to graph it. You just have a vertex at h and k, and your quantity x squared there. And then what is the graph called? It is a parabola. So that's what we have been doing in the past. Pause that if you don't have it, because I'm going to the next part of the notes. What have we done in the past? What's old? The graph would either open up or down. Now we can have graphs open left or right as well. So in this lesson we're going to have it going up or down, or it could also be opening to the right or to the left. And in the past we would always solve for y, just like in our equations here, f of x equals. But now we can solve for x squared or y squared. Okay, that's a little weird. What we're solving for the quantity squared in this case, not solving for y. So let's label a little graph here. Vertex, that's easy. Vertex is just right there. Axis of symmetry, that's easy. Axis of symmetry there. Now let's do some stuff that's new that you probably haven't done before, and that is a focus. The focus just goes anywhere inside the parabola there. The distance here, we'll talk about what that is just a second here, but just anywhere inside, and label that dot the focus. The distance from the vertex to the focus, we call that a distance of the letter p. So that's important for our formula that we'll write out. That distance is a p. Now directrix, this is also something that's kind of new to you. You will probably not have seen this before. And this is some imaginary line on the other side of the vertex. So if you have a focus, you go the other way, there's your directrix, and the distance from the vertex to the directrix is also the value of p. Now why do we make this so complicated? Well, it actually has some really cool applications, but one thing is, if I choose any dot on the parabola, so I'll just have that red dot there. If I draw a straight line to the focus and a straight line to the directrix, okay, now my scale is not correct. Okay, I kind of messed up on this. But this line and this line should be exactly the same. I just threw mine out here, so it's not perfect. But if it was a real parabola that we were drawing, these two distances, the distance from that point to the directrix and the distance from that point to the focus, would be identical. So the real cool application comes with this thing here with the focus. This is a representative of, let's say it's a satellite dish or anything where that's bouncing down, hitting the parabola. If it bounces straight perpendicular to the directrix, so if I have some directrix here, and these lines here are coming down perpendicular to the directrix, it's going to bounce off and hit the focus. Well, what type of things do that? Look at this little movie clip here. One of my favorite movies. What in the world is that? This is in Puerto Rico. This is the world's largest satellite. It's pretty cool, huh? Huge. So you can see, let me pause this. You can see if anything came down, signals came down and bounced off of this parabolic dish here, it would go back up and hit the receiver that's up above her head. Amazing stuff. So that's just one little application we've got. Now on to transformational form, and this form you really need to be good at. Notice we have the quantity squared here by itself. This is if the thing opens up or the parabola opens down. That's what we're used to. I mean, think about it. We'd have y equals x squared. We're used to the x being squared, so that's not a big deal. So when the x is squared, in this case, it opens up or down. So you have the vertex at hk just like we had before. Here it's a minus h and a minus k, so that means it's the opposite of these two things here. And then this is weird, 4p. In other words, the number that is the coefficient right in front of the linear term, again, not the quadratic term, in front of the linear term here, that represents 4p. So if we divide that number by 4, we get p. And remember what p is? P was the distance between the focus and the vertex. So then we go to opening left or right. How do we know if it opens left or if it opens a right? The y is being squared. This is what we're not familiar with. But notice the h and the k, the h still goes with the x. The k still goes with the y. So don't swap those. Be careful about that you're not getting them confused. The h always goes with the x. The k always goes with the y. And again, you have the 4p. If the front is negative, that's how you know if it opens left or down. If the front, this leading coefficient here, if this is positive, then it either opens up or opens to the right. So get those down if you don't have them yet. And what is p? We've already talked about this. It's the distance between the vertex and the focus. It's also the distance between the vertex and the directrix. What is the distance between the focus and the directrix? So what I'm talking about here is you have some focus, you have a directrix, some imaginary line. What is that entire distance? Well, if it's a p there and a p there, the entire distance is 2p. Our first example, number 1. I've listed these things for you to do because if you will do this in that order, it will help you to sketch an accurate graph. So first thing is find the vertex. Well, the vertex is just right there, that number with the x, the number with the y. Just make sure you're taking the opposites of these things. So -2, 1, there is our vertex. Next, which direction does it open? We need to identify that. Since the x is being squared, it is a normal type of parabola that we're used to. And since it's positive in front for that leading coefficient, it opens up. The next thing, axis of symmetry. The axis of symmetry is going to be right splitting it down the middle there. So that is x equals -2. That's the type of thing we've done before. Coordinate of the focus. In order to calculate that, we need to know what p equals because it's going to be p away, p units away. Well, that, our number 8, is our 4p. So what does p equal? If we divide both sides by 4, then p equals 2. So that's an important thing that we need to be able to do on each of these is know the distance p. So you start here at the focus, or excuse me, the vertex. We know it opens up, so we go 1, 2, there is the focus. So the coordinate point of the focus is -2, 3. And then the equation of the directrix. So the equation of the directrix, I'm going to draw another red line here. Whoops. Where is it? There we go. I'll draw another red line. It is going to be 2 away from the vertex. So I go down 2, and there is my directrix. Okay, now we can, I forgot to write the equation. The equation is y equals -1. So now we're trying to sketch this. So how do we sketch this graph accurately if this is all we have? Well, I could plug in some points. I mean, I could plug in some different points here, but we're not going to make it quite that accurate. The important thing here is to understand the vertex and then just get a basic shape of the graph. So we'll come back to graphing it. Let me show you something else on your notes. Go to this part of the notes, the focal width. The width of the parabola at the focus is 4p. Let's repeat that again. The width of the parabola at the focus is 4p. So if I were to draw a picture of what that represents, if I had this parabola going up and some focus here, then the distance across this thing from this distance to this distance all the way across is 4p. So from there to there and from there to there all the way across is 4p. So let's go back. What is 4p? 4p was 8. So when I'm trying to go up here to the focus, that means I go 1, 2, 3, 4 this direction, and 1, 2, 3, 4, it's off the grid a little bit, this direction. There's my parabola. And that can help you sketch the thing from there. Oops. Sketch. Okay. There's our sketch. Well done. On to example number 2. I'll pause this, let you try it out on your own. Do exactly what we were just doing. Notice, before I pause, notice that y is being squared, so you got to think about which direction it's opening. Okay, I'll have the answers appear in just a second. Okay, there's your answer. Should be a parabola opening up to the left. There's lots of places that we could be making mistakes here, so be very careful. Like, for example, the vertex was 4, -1, because you had to start with the x value. It had to open left because y is being squared, and the 4p is negative. We had to figure out what p was here. 4p equals -6. Solve for that one. You get a -3/2. So then that means from my vertex, I went left 1.5 and right 1.5. That's how I got my focus and my directrix. Okay, and then where did I get these points from? That was my 4p. Since my 4p was a 6, -6, I went 3 up and 3 down to get my focal width. Okay, so look through that one, pause it, see if that one makes sense. You might need to ask some questions or star that one for your teacher if this one doesn't make any sense to you. Before I do the next example, I want to show you a little clip I made a few years ago with a flashlight. I know I'm being kind of dorky in here, but it's interesting stuff.
So I have here the flashlight. I've taken off the head of the flashlight here, and we're going to look at, as I take this apart, going to see inside there is a parabolic mirror. And you can see the little light bulb that I'm going to pull out there. And so there is the gap inside the mirror. And you have this mirror image. What will happen is, with that light bulb, if I stick that back up inside there, that light bulb is the focus of the parabola. So the light that shines straight to the mirror will then bounce directly off and come straight out. And that's how a parabolic mirror works. You can see here my light that's shining against a wall, and that dark spot that's right in the middle, that is because of the bottom of the parabolic mirror, where the vertex is. That's the gap in the mirror spacing so that it's holding the light bulb. And so the light is not reflected and concentrated quite as much as it is all around where the mirror is.
Now really, how cool is that? I mean, you got a flashlight that you use you've probably used that a dozen times, 100 times, whatever, camping trips, and it's using parabolas and you didn't even realize it, these crazy equations. Let's go on to number 3 and 4, and for these problems you will have to create the equation given some information here, like maybe a vertex, a focus, maybe I'll give you the directrix, some different information. You're trying to come up with the equation. Now here I've given you a hint in your notes, and I'm going to try and put this in the practice as well to remind you. These are some steps that you can go through that will really help you out to get the equation that you need. So I'm going to make this kind of big to put that in the corner down here, and I'll refer back to that several times. So the first thing is sketch a graph of the given information, and that you maybe even want to star on your notes. This is things that kids fail to do. Every time a kid misses it, I'll go and say, all right, where's your little sketch of a graph? And they're like, oh, I don't have it, Mr. Bean. Well, yeah, you're going to miss it if you don't do this. Okay, let's do this. Create yourself a quick little grid like that, a coordinate plane, and let's put down a coordinate point of 1, -4. So 1, down 4, put a dot. Okay, it really doesn't matter, it's just all relative here. This is the vertex, and then where's the focus? 5, -4. So I'm going to go over here, 5, -4. Oh, wait, 5. 5, -4. So if that's the focus right there, and this one here is the vertex, that means it must be opening to the right. Okay, so that's what I mean by sketch a quick little graph of the given information. Number 2, let's take this. We're going to write down a shell of things of what's happening. So quantity squared equals 4p, open parentheses, close parentheses. Okay, what else? Identify if 4p is positive or negative. Well, if it's opening to the right, this thing is going to be positive. Okay, so I know that. What is being squared, the x or the y? If it's opening right or left from the notes before, we know that y is going to be squared. So we can plug in a y there and an x there, since the y is being squared. Find the vertex. Well, we already know the vertex. It's 1, -4, so that's pretty easy. So let's go a -1. The x goes with the x, and then the y here goes in with the y. It's a y plus 4, because we're talking about the vertex. And what else now? We're going to find p. So here's my equation. I have everything I need except for the value of p. Once I have that, I'm all done. So let's think about this. What is this distance right here? That distance. Well, if this is 1, -4, and this is 5, -4, that's a distance of 4. See, from 1 to 5, that's a distance of 4. So you just got to think about what's the distance there. Just think common sense here with the coordinate points. So that means that my value of p is 4. Now that I figured out what p is, I just plug it into my final equation, and I am done. So let's go here. My final equation is y plus 4 quantity squared equals, plug in a 4 there, I'm going to get a 16x minus 1. And then let's just double check and make sure that if it's positive or negative, it is opening to the right, so it is positive. So this is a positive right there. That's just this thing, double check positive or negative, okay? Not too bad if I've got these steps here for you, hopefully, and as if you do enough of those, it will become a little bit of second nature. So we're going to try number 4. I've got the steps again that you can remind yourself of. So you're going to pause the video now, try and sketch this information that you're given, and see what you come up with. Okay, I decided to only go this far because I wanted to make sure that you get correctly written out the vertex. So what I've done here is I've written out what they've given us, -3, -6. There's the focus, and that's the key here. It's the focus, not the vertex. Be careful about that. Missed problems on mastery checks come from that. And then y = 1 is the directrix. So the vertex has to be right in between these values. So what in the world is the vertex? Well, the vertex right there, that V vertex, is going to have the same x value as the focus. So we can say that the vertex is at -3, comma. How do we get the y value of the vertex? You want to go halfway in between these two things, which really means you're going to take the average. So we just say -6 plus 1, because that's the y value here and the y value here. You add them up and divide by 2. That's how we get right in the middle. It's the average of the two. So the vertex is -3, comma, what's this? -5 halves. That is the vertex right there, or -2.5 if you wanted to do it that way instead. So then we can come over here to the vertex, and you say x plus 3 and y plus 5 halves. Okay, we're getting there. Now you just need the value of p. So what is the value of p? What's this distance right here from that vertex to the focus? If that focus has a value of -6, and this one has a value of -2.5, how far apart are those two numbers? Well, you just have to subtract them. So let's do -6 minus a -2.5. That gives us -6 plus 2.5, which is -3.5. So -3.5 is the value of p. That's this distance from there. Let me use a different color. not throw you off, that distance right there. So you can just subtract the two numbers and you get the value of p. So p is negative 3.5. Now the thing is we want to do 4p. So if you multiply this by 4, so what does 4p equal? 4p is, double that, I get 7. Double it again, you get 14. So 4p is a 14. So let's go to my answer. It is x plus 3. And the x is squared again. Why? Because it's opening down. And because it's opening down, this has got to be a negative. The 4p is negative 14. And then y plus 5 halves. And then the final step is just double check if your 4p is positive or negative. Okay, we're done. You made it through your first lesson on conic sections. Nice job. Rock that mastery check, and I'll see you back in the next lesson.
This is Mr. Bean, and I'm going to give just a little... And, welcome back. We're going to do another lesson in Algebra 2.
You make it again.
Okay, all right. Back to Algebra 2 lessons on conic sections. We're going to start learning about conic sections. The way this works is and you slice it at an angle, and then when you... Ooh, very good. Thank you, Mr. Bruss. Okay. I'm not really doing anything.
Don't even get the pie there. Just get your head.
I know. Well, yeah, I could do that. I could take out...
Yeah.
Or what if octopi, like, across the screen? It floats.
He's going to spend 8 hours editing this. It's going to be a 30-second clip.
This is what behind me coming after me.
Coming after you. I just need a copy of this without anything behind it. I want the straight-up unedited version. My videos will be funny.